Hello friends, welcome to Chandu's Smart Class. This is Chandu. In this session we are going to discuss about DES, Data Encryption Standard. So it is a symmetric block cipher. It is a symmetric block cipher and it is published by NIST. NIST means National Institute of Standards and Technology, and initially in 1973 IBM designed an algorithm DES which came from the modification of existed algorithm Lucifer. The old name for DES is Lucifer. It is modified by the IBM to DES and it is published by NIST, National Institute of Standards and Technology. After that, some criticism has been done on DES. Mainly there are two reasons. First one is key length. The key length of the DES is very small, that is 56 bits, so it is vulnerable to brute force attack. And second one, the internal structure of DES, which has a trapdoor for attacking. It is identified by National Security Agency. Okay. So based on these two reasons, some criticisms has been done on DES. After that, IBM modified the DES and improved the security of DES. The final version of DES was released in 1977. After that, it has become most popular symmetric block cipher, most popular cryptographic algorithm in 1970s. After some time, they improved the security based on the key length and has developed 3 DES, triple DES, which contains DES 3 times. So 3 ciphers are there in the 3 DES and the key length will be increased. Okay, this is the history of DES. Most importantly, it is a symmetric block cipher. So we already discussed about block cipher. The block cipher means the plain text will be divided into blocks and it will be encrypted at a time and ciphertext will be generated. Plain text will be divided into blocks and each block will be encrypted and generate ciphertext. Okay, and each and every character in the block contributes in the encryption of other characters. That is the phenomenon of block cipher. The encryption will be done in the plain text blockwise. Okay, so before going to the basic structure of DES, first we need to discuss about the basic terminologies. So it is a block cipher. So what is the block size of DES? Block size is 64 bits. Okay, 64 bits plain text. Plain text will be divided into blocks and each block which contains 64 bits. And next thing, round. So here we need to use Feastel cipher, Feastel structure as the round function. Each round is a Feastel cipher and there are number of rounds. Number of rounds are 16 number of rounds are there and each round which contains Feastel structure, Feastel cipher. We will know about Feastel structure later. And cipher key that is 64 bits and round key size is 48 bits. 64 bits will be divided into 16 48 bit keys. Those are sub keys. we need to generate the 16 48-bit keys, and each 48-bit key will be given as input to each round. So for total 16 rounds we need to give 16 48-bit sub keys, that is called round key. Okay, so block size is 64 bits, 64 bits plain text, and generate the 64-bit ciphertext also. Okay, 64-bit plain text and generate the 64-bit ciphertext. Here we need to perform the data encryption standard DES in 16 rounds. So each round has a physical structure. The key size is 64 bits, and for each round we need to give a round key, that is sub key. The length of the sub key is 48 bits. We need to generate 16 round keys from 64-bit cipher key. Okay, so these are the basic things we need to know before going to actual procedure of DES. I hope you understood. So if you learned something from this video, please like, share and subscribe. Thank you. Thanks for watching.